Look at future value annuities. So this is a future value formula. The present value of an annuity is actually a different formula, so just keep that in mind. We'll read this, then we'll talk about all the variables involved, and then we'll attempt to solve. To save money for college, Rona, I guess that's how you say that, plans to deposit $250 into an account at the end of every 3 months for the next 2 years. She will begin making payments 3 months from now if her account has an interest rate of 4% per annum per year, compounded quarterly. How much will Rona have after she makes her last payment? Okay, how is this different than compound interest? Well, if compound interest, I would just make one payment of $250 into a bank account, so I put $250 in, and then I just wait every single month as the interest occurs. In this one, or every 3 months as in this case, in this one we put in $250, okay, we get some interest, and then that month again we put another $250, and we get interest, and then we put another $250, get interest, and then we put another $250. So we're actually investing every month while accruing interest. So that's the difference between an annuity and just a regular compound interest formula. Okay. So what does that mean for us here? A lot of the variables are the same. FV I've used before. That just stands for the future value. Okay. Future value. PMT or R. I don't know how your teacher is going to define it. PMT is usually known as the payments, or R is, they call them regular payments. They are the same thing, okay? Payments. So whatever we highlight them, let's highlight them yellow. They are the exact same thing, these two things, okay? This sometimes use different letters for them. One is 1. I, again, just like compound interest, is R divided by C. R is interest rate, and C is compound, period. And if we've done compound interest, we're familiar. N, same idea, is compound period times number of years, so we already have C. YR is years. So really, the only thing that's a little different here is these regular payments, as opposed to what they usually would consider this the present value. These are called regular payments, and the assembly of the formula is different from a compound interest formula. But otherwise, the variables are essentially the same things. Now, this question is a little tricky, so we're going to read it again, define our variables, and then talk about how the payments are being made. So, Rona deposits $250 every month, so that means our PMT here, or our regular payments, are $250. So I'm going to just kind of define them on the side here. I'll call it R. R is $250. So we'll keep that in mind. At the end of every 3 months, okay, that's important, for the next 2 years. 2 years, that's our yearly amount. Okay, so that's our YR in this case. So we know YR is going to be equal to 2. Equals 2 years. 2. She'll begin making payments 3 months from now. This is an important sentence. We're going to come back to this sentence. If her account pays an interest rate of 4% per annum, so 4% a year, that's our R value. So R is equal to, and I'm just going to convert it to a decimal, 0.04. Compounded quarterly, okay, so our compound period, that's our C. That's going to be equal to 4. So C is equal to 4. That gives us enough to solve for. You see the compound period occurs in both of these. We have years, so we can solve for the N. We have R, the interest rate, so we can solve for the I. The only thing we don't know is future value, so we can plug everything in. How much will Rona have after she makes her last payment? Okay. We're going to plug these things in, and then we're going to do a little work to manipulate N because of the way they've worded this formula here. Okay, so let's plug our things in. FV is still FV. We don't know the future value that will be in the account. The payments are $250 at the end of every 3 months. 1 is still 1. I is our interest rate, so that's our 0.04 divided by the compound period, which is C. To the power of N. N is
4.
Oops, thank you. I just wrote C, didn't I? 4. N is 4 times the number of years. Our number of years in this one was 2. But again, I'm going to manipulate that, so just make a note of that. We're coming back to that amount. and this 250 is outside. This is actually subtracted by 1, and then all of that is divided again by I, which is a formula again. It is 0.04 divided by the value of 4. So the calculation is a little more complex, but as long as we put it correctly in our calculator, not really that much for us to do. Okay, let's speak to this. So if it's for 2 years, 4 times a year, obviously it's going to be 8. I don't know why it took me long. Every 3 months. Okay, it's going to be 8, but let's read this one more time. It says, to save money for college, Rona plans to deposit $250 at the end of every 3 months for 2 years. She will begin making payments 3 months from now. Okay, so if we're looking at like a timeline here, I'm going to try to set up our timeline of 2 years, or 3 years. Let's say this is now, and this is the end, which is in 2 years from now. And the periods that she has, we know that the middle is 1 year from now, and she's doing it 4 times a year, correct? So 1, 2, that doesn't make sense. Why doesn't that make sense when we do it? So we did it now, there. No, I'm putting too many in here. I did it right now, 3 months. That's how we do this. 3 months. There you go. That makes sense to me. 3 months, so that's 6 months. 3 months and 3 months. That makes sense. 3 months, 3 months, 3 months, 3 months. Okay, great. Sorry that took me so long. She would have 1, 2, 3, 4, 5, 6, 7. No, that didn't work out. I'm going to pause this. So this is why it's tricky. We'll talk again. The first payment is done here in 3 months. So we don't actually have any money now. So we're not earning any money. We make our first payment here. That's number 1. Then there's 2, 3, 4, 5, 6, 7. And then we don't actually make a payment here. This is when we take all of the money out. Okay? And also, even if you did make a payment there, you would have earned no interest, so it's just like having $250 and keeping it in your pocket. There's no interest payment. Which means there's only one, again to count, 1, 2, 3, 4, 5, 6, 7. There's actually only 7 payments in this case. Okay? If they had made a payment right now, then we would have had the traditional 8. But because we don't make our first payment till 3 months from now, it's actually only 7. So this isn't quite right. This number should be just 7. Okay? It's a tricky question because of this sentence. Had that sentence not been included, we could have just gone straight forward with all the numbers we had and gone through it. Okay? So now that we know that, we can change this value to exactly 7, and then we can go through the formula. Our F of V is equal to, I'm going to write down here so we know 7 payments is equal to 250 multiplied by all of the rest here. So the rest of this is 1.01 to the power of 7. Instead of 8, we're writing the value of 7. That's going to be subtracted by 1. And all of that's going to be divided by 0.01. 0.01. That's what that equates to. This part's not so bad in the calculator. We should be able to do this relatively easy. So 1.01 to the power of 7, subtract 1, but take that and subtract 1. There we go. There we go. And then we take this value and we're going to divide it by 0.01, much larger now. And then we take that value and multiply by 250. And here we go. At the end of the 2 years, we have $1,803.38. $1,803.38. Okay. Now, how would that have been different had we made that other extra payment there? I'm going to just show you. I don't have to go through the process again. This would have been the power of 8. So we would have done 1.01 to the power of 8. That would have been subtracted by 1. then divided by 0.01, and then multiplied by, I think it took my last name, so 250, 207141. I'll write that in. 207141. I just want to show you the difference between these two numbers. If we take that value and subtract by, that was our number, it's more than $250, which were each of those payments. We clearly earned that much plus a lot of interest, okay? So it would have been much nicer had we been able to make that payment right now. For what this question is asking, our answer is they'll have $1,803. Is that what they're asking? After she makes her last payment, $1,803, because she doesn't make that very first payment. Otherwise, the answer would have been this one here. Okay? This one is a little more tricky of a question.